All right, good people. Welcome to video number 2. We're going to find the area between these two curves, and again, between this parabola and this line. So that would be this shaded region right here. So the first thing is we need to know, where are the intersection points? Do we know the intersection points? Well, we do. There's one right here, and then there's one right here. So this goes from x equals 0 to x equals 3. Now the question becomes, in the last two examples that we've seen, we've been given the graph, and those intersection points land right at a nice whole number x value, right? What happens if it doesn't? Or how would I do it with didn't have a graph? Well, if we're trying to find where the two graphs intersect, then we're really saying, can you take this equation and set it equal to that equation? Because the deal with this is that the y-coordinate of the curve is the same as the y-coordinate of the line, right? And so then you would take negative x squared plus 4x plus 2, set it equal to x plus 2, and then wherever those two meet, that would be the answer. So you would have to solve for this. So there's many ways to do it. I guess I'm going to move stuff to the right side, make this positive x squared minus 3x. Oh, and that's 0. So if I add this over, subtract the 4x, and subtract the 2, this is what I get. And I can factor out an x, and then I can solve it like this by saying, oh, what makes this equal to 0? Oh, that would be x equals 0 and x equals 3. Okay, so I'm showing you how to do it by hand. Later, we're going to do this, but we're going to do it with a calculator. We're going to find the intersection point. But here's a nice thing. We already know, hey, my integral is going from 0 to 3. Great. Next part. I'm going to draw a representative rectangle. You can draw it wherever you want. I just want to check which function is on top, which function is on the bottom, and is that always the case? So wherever I draw a rectangle, I don't know if I said triangle, I'm sorry if I did, but if wherever I draw a rectangle, which function is always the top boundary? Because that is going to be the one I write in first. So negative x squared plus 4x plus 2, this curve is always the top part. And then the line, x plus 2, is always the bottom part. So when I set up my integral, I'm going to say top, all of this, minus the bottom boundary, which is x plus 2 dx. This integral will find the area that's trapped between those two curves. It's trapped between the top and the bottom. So that's why I said negative x squared plus 4x plus 2 minus x plus 2. Now we're going to take the antiderivative. So let's take the antiderivative just to practice our first part of the fundamental theorem. By the way, I can reduce this a little bit more. This would be negative x squared, 4x minus 1x, that's 3x, and positive 2 minus 2, that's 0. So I'm left with this. This is what I'm going to find the antiderivative of. This is a 3, by the way, plus 3x squared over 2. And we're going to evaluate that at 0 and 3. Remember this line that I write? This line right here means we're going to evaluate that at the top limit and the bottom limit. It's kind of a reminder, hey, don't forget to go back and actually substitute the values. When I do substitute the values, be careful, the negative's on the outside. I'm going to get this over 3 plus this over 2 minus, and when I plug in 0, well, wait a minute, 0 to the third power is 0 divided by 3 is 0, plus 0 squared is 0 times 3 is 0 divided by 2 is 0. So that second part goes away. Like, we don't even need to write it down. Let's finish this. Negative 27 thirds. Wait a minute. Isn't that just negative 9 plus 27 seconds, or halves, I guess? I believe that's what that is. Yes. Let's see. What can we do? Oh, we said this was negative 9 plus this is 13 and a half. 26, 27, yeah. So then my final answer is 4.5. And we're done with finding the area between the shaded, or finding the shaded region between the two functions. That's it. Okay. I'm going to skip to number 4 because they give us a graph for that. Number 3, we're going to have to use a calculator. So I'll set up the calculator for it to go a little bit faster during the break. But let's do number 4. Two graphs. One of them is the square root of x. One of them is the line negative 1/2 x squared, negative 1/2 x plus 4. Find the area that's enclosed by these graphs and the x-axis. So between this graph, and the x-axis. So we're talking about this. Kind of looks a little oniony, but not really. Okay, so enough of the shading. This is what we're looking for. So again, I'm going to draw a representative rectangle. So here's my rectangle. I notice that the square root is the top function. So I'm going to do that in green. And the bottom function is the x-axis. That would just be 0. Y equals 0, right? This is y equals square root of x. But if I move along, eventually that square root of x is not going to be the top part. The top part is going to be this line. So that's negative 1/2 x plus 4. And then the bottom is still y equals 0. So what I have to do here is realize, hey, my setups are going to be different because in the first part, you can even say in the first half, this is the top, this is the bottom. But once I get to 4, now this is the top and this is the bottom. So I have to set up two integrals. One of them is going to go from 0 to 4. And then I'm going to add it to the other one that goes from 4 to 8. And that's because in the first part, this is the top minus this is the bottom. And I can put the dx to close that out. And then in the other section, this is the top. And I'll put this in parentheses, minus, and then the 0 is still the bottom. And I'll call that dx. Top minus bottom. That's how I find the height of these rectangles. And then the integral, and then the dx is the delta x, the width of the rectangles. And then the integral is going to add an infinite number of them to kind of sweep through and give us the shaded region that's trapped between those two. Okie dokie. Let's see. Well, let me fix this. Square root of x minus 0, that's just the square root of x. And the square root of x is x to the 1/2. So if I take the antiderivative, I believe I get this. And then I'm going to evaluate that at 4 and at 0. So that means I'm going to plug in the 4 first. Plug in the 0 second. But as I'm doing that, I'm realizing, hey, that second part's going to go away. And the first part, if I have a 3/2 power, that means the half is going to take the square root. So this is the square root of 4, which is 2. And then take it to the third power. So 2 to the third power, that's 8. So 4 to the 3/2 means take the square root of 4 and then take it to the third power. And so this is really 2 times 8 over 3, which is 16/3. Okay, so this first part is done. Now I need the second part. So we're going to add on the next part. So I'm going to take the antiderivative. So the antiderivative is negative 1/2 x squared over 2 plus 4x. I'm multiplying these two. We're going to evaluate that from 4 to 8. Just to fix this a little bit, this is negative 1/4 x squared. So I'm going to erase this and just say negative 1/4 x squared. So that when I substitute the 8 plus substitute the 8, that'll be the first part, minus substitute the 4. And substitute the 4, that's going to be the second part. Okie dokie. By the way, the first part I have is 16/3. Let me keep it flowing down. Let's see. 64 divided by 4, that's negative 16, plus 32. Here I have to be careful. I have a negative and a minus, so that's going to become plus. This is 16 divided by 4, or 1/4 of 16, which is 4, and then minus 4 times 4, which is minus 16. There's many ways to do this. I can say this is 36 minus 16. That would be 20 plus negative 16. That's 4. So this whole thing becomes 4. I could also say this and this is 16 plus 4 is 20. 20 minus 16 is 4. Either way, And then when I put these two together, I can say this is 28 thirds. Why? Because 4 is the same thing as 12 thirds. And then now that I have a common denominator, I can put them together. And there's my answer. I'm doing this quickly and I'm doing this by hand, right? Do you always have to do by hand? No, we're going to look at the next video that you really don't. But I want to make sure that you understand the setup. This is the important part, right? This is the important part. Then everything else is things that we've done already. Take the antiderivative, plug in the top number into the antiderivative, plug in the bottom number into the antiderivative, subtract, and then that's going to be your answer. If you have to do things by hand. In the next video, we're going to see that you don't always have to. You just have to set it up and then solve it using the calculator.